All right, guys, welcome to lesson 6.8. This is our last lesson in Unit 6. So after this, we'll be hitting up a study guide and doing a test. So 6.8 is actually going to look really familiar. It's going to be almost 100% of what we did last time. The only difference is now I'm going to make you do some factoring in the process instead of having me just do it for you. Okay? We're going to be graphing polynomials using everything that we've learned in the past 7 lessons. So here are the steps. I would encourage you guys to, write those down. If you want to, it might be useful in the test. But we start by finding the roots. Now, to find the roots, that's a 3-step process. You've got to set your polynomial equal to 0. You need a factor, and then you set each factor equal to 0 and solve. And that's honestly the step that's going to take most of the work, especially because of part B, which is factoring. And as you guys know, that's a little bit of a chore in and of itself, okay? After we get past that, the bad part's done. Step 2, we can move on into the multiplicity of each root, and then we can determine whether the graph goes through or bounces off of each root. Step 4, we find the y-intercept. Step 5, determine the end behavior. Step 6, we're ready to graph. And to do that, you'll plot your roots. You'll label them with a T or a B, whether they go through or bounce. You'll plot your y-intercept. You'll sketch the end behavior, and then you connect it all together to make a graph. So without any further ado, let's go ahead and jump into one of these, and let's take a look at example 1. Okay, so step 1 is to find the roots, and to do that we have 3 sub-steps we need to do. The first sub-step, 1a, is we need to set this thing equal to 0. Step 1b is we want to factor. Now, whenever you factor, there's some sub-steps even for that. And so the first thing you want to do is you want to see if there's a GCF that you could take out of here. So is there anything you guys can think of that would go into 8 and 50? What's the biggest thing you can think of that would go into 8 and 50? I think the biggest thing is 2. Now, personally, I don't like having negatives in the front like this. So whenever I have that, I also like to take that out in the process as well. And how many x's can we take out of there? It looks like we could take out 1x. Now let's see what's left after we take out our GCF there. If I divide this by negative 2x, I'm going to be left with positive 4x squared. And if I divide this by negative 2x, I'm going to be left with minus 25. Okay, the next thing we do is that we either do difference of squares or box method. And as you guys can see here, this is a difference of squares problem. So I'm going to go ahead and factor that now using the difference of squares method. So you square root this, and you square root that. You make one a plus, you make one a minus. So that's the end of step 1b, factoring. Let's move on to step 1c. Step 1c is where you take your factors and you set each one of them equal to 0, and then you solve. So for the first one here, we're going to divide both sides by negative 2, and that's going to end up giving us 0 as an answer. The next one, we're going to minus the 5 first on both sides. And then we're going to divide by 2 after that. And so we end up with x equals negative 5 divided by 2 is about negative 2.5. I would suggest changing them into decimals if you get a decimal one. The next one, we're going to add 5 on both sides. And then we'll divide by 2 again. And for that, we get positive 2.5. So there's my roots. Now we move on to step 2. So that's the end of step 1, and it's 3 parts. 3 parts are set it equal to 0, factor it completely, and then set everything equal to 0 and solve. And that's the end of step 1, finding the roots. Now we move on to step 2. Step 2 is where you determine the multiplicity of each factor. So my factors are negative 2x, 2x plus 5, and 2x minus 5, and the multiplicity is determined by their powers. Now none of them have a power on them, which means they all have a power of 1, which means that all of these roots have an odd multiplicity. Step 3 is to determine whether we go through or bounce. Well, when you have an odd multiplicity, you go through. So they're all throughs. All right. Next step, step 4, is to find your y-intercept. And you're going to do that by going back up here to your original equation, which is negative 8x to the third plus 50x equals y. You're going to plug 0 in for the x, which I'll show my work this time, but you're going to find that that's kind of unnecessary. Because anything with an x just goes to 0, and in this case my y-intercept is 0. All right, step 5, we determine the end behavior. Now whenever you're doing end behavior, we only pay attention to the first term. I've got a negative coefficient with an odd power. And when we have that, that means we go up on the left, down on the right. My last step is to go ahead and start graphing. And when we graph, we start by plotting our roots. My roots were 0, positive 2.5, and negative 2.5, which would be approximately here and here. My y-intercept was, oh wait, actually before we get to that, the next thing you do is you determine whether they go through or not. Now all of these are through points. We're not going to have any bounces on this one. The next thing we're going to do is we're going to plot our y-intercept, but my y-intercept is already there, so I don't need to do that. Then the next thing we do is our end behavior. So it's up on the left and down on the right. And so if I connect these by going through, 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 that's what my graph would end up looking like. Okay? So there's one problem. Let's go ahead and do a guided practice here. All right, so I want you guys to do step 1, which has 3 parts. You're going to set it equal to 0, you're going to factor, and you're going to solve. So pause the video here and see if you could take care of step 1, finding the roots. All right, so here's the result. First thing we should have done is we should have taken out an x squared after we set it equal to 0, of course. So technically you set it equal to 0 first. And then I took out a GCF, which was an x squared. Since this term here had this polynomial had 3 terms, I did the box method. And after doing the box method, we end up with this. Now, something you guys probably didn't do, because bad teacher, Mr. Bailey, forgot about giving you an example like this. Since I had the same binomial written twice, I went ahead and just rewrote it like this. So if you didn't do that, I would encourage you guys to stop now and do that now, because that's important. That's going to affect our multiplicity issue later on. So anytime you guys, after you factor, if you had the same factor twice, I want you to rewrite it once with a power of 2. That way it'll look a little bit more like the problems that we did before. Okay? But regardless, you set x squared equal to 0 and solve, and you should get x equals 0 for that. And then you set 3x plus 1 equal to 0 and solve, and you should get negative 1/3 for that. Okay? So now I'd like you guys to go ahead and pause the video here, and I would like you guys to go ahead and do steps 2 and step 3. Do steps 2 and 3, and when you unpause it, you'll see the solution. And there you guys go. Step 2 is to determine whether the multiplicity for each factor was even or odd. And the first factor, x squared, has a power of 2, so that's an even multiplicity. And the second factor, 3x plus 1, also has a power of 2, so it also has an even multiplicity. And therefore for step 3, since both of those have even multiplicities, that means in step 3 that both of those roots will be bounce points for our graph. All right, go ahead and pause the video here and do step 4. Now for me in step 4, the answer is just going to be y equals 0 is the y-intercept. To do this one, you plug 0 in for x into the original equation and you solve for y. And that's that. So that one's pretty straightforward and quick. I'm going to label my steps here so everything doesn't run together. Okay, go ahead and pause the video here and do step 5. Step 5 is to find the end behavior, and since the leading term was a positive coefficient with an even power, that means it's up on the left and up on the right. All right, now is the drum roll time. Go ahead and pause the video here and see if you guys can accurately graph this thing. And there you go. It should look something like that. It has a root at 0 and 1/3, and for both roots it bounces off of the x-axis. And the left and right side should go upwards, and we don't have any extra points. The y-intercept is the same thing as the root right there at the origin. All right, so let's do a student practice now. Okay, so here's one for you guys. Go ahead and pause the video, and I want you guys to take this thing all the way home. I want you to do every step and get me a final graph. All right, so here we go. Step 1, set it equal to 0. Step 2, factor it. And since there's 4 terms, I went ahead and did the box method there, as you can see at the right. And I got x squared minus 16 times x plus 3. And then we have a difference of squares there, as you can see. X squared minus 16 becomes x plus 4 and x minus 4. I don't have any factors repeated this time, so I'm not going to put them together as a square. Let's go ahead and move on to the next step, where you set each factor equals 0 and solve. And that concludes step 1. So my roots are -4, 4, and 3. I'm sorry, -3. Step 2 is to determine the multiplicity. Now, since all of these factors had an odd power, because none of them were repeated, they all had an odd multiplicity. And since they all had an odd multiplicity, that tells us that each one of those roots for step 3 were through. So my graph is going to go through the x-axis at each one of those roots. All right, so let's go ahead and proceed onward a little more. Step 4, the y-intercept is -48. That's a really big y-intercept, but if you plug 0 into the original equation and solve, you'll just be left with that -48 at the end. And then for our end behavior, since my leading coefficient was an x to the 3rd power, a positive coefficient with an odd power results in us going up on the left, right, and down on the left. And at that point we're ready to graph, so let's go ahead and give it a graph and see what that looks like. And there it is. So it goes through the x-axis at -4, -3, and +4. It touches the y-axis at -4, and then it goes up on the right and down on the left at the end behavior points. So there you guys have it. So that's the basic idea there for graphing polynomials from the beginning.